Sriram Nimnal. Sriram, if you are hearing, just confirm by saying yes. Sharan Ram. Sivaranjani. Nitish. Joel. Manoranjan. Vatsal Bharadwaj. Confirm that you are able to hear me just by saying yes. Nikas, Abhinand.
Yes, sir. Yes, sir.
Fine. So,
Excuse me, sir. Actually, I have video on my camera. The camera on my camera.
who is that? Shivaranjani.
Yes, sir.
Tell me what you are saying.
Sir, I don't have camera in my gadget, sir. Maybe the next class I will new gadget and then.
No issues. You can come to for the offline class hereafter. This is the last online class you are attending. If camera cannot be on, you have to come for the offline class. Okay.
Yes.
Today I am allowing you to attend, but if your camera is off, then we will not allow you to attend the online class. We have offline seats there. You can come and attend offline like how your friends are attending. Okay. I hope it is clear to everybody. Fine. So, I have like students from various places who have joined here, and let me first brief you about the plan, because some of you will be confused that a topic of fluids is remaining and we are into thermal properties of matter. SSM children will be confused that we are in the starting of fluids, but we started next chapter. I think in some school they announced they are going to have waves and oscillations in the upcoming examination. You will have another problem. So, problem is going to be there for everybody. Let me tell you the correct exact plan how I will overcome all this problem. Fine. So, here in this class, it starts with thermal properties of matter. Today I will teach thermal properties of matter only. Okay. After that, next class also I will be finishing this chapter. Then we will go to thermodynamics. Then we will go to KTG. We will go to waves. We will go to oscillation. It will go in the same way hereafter as the syllabus goes in the book. Okay. Whenever I come to SSM Nagar, I think I will be coming there, I think on every Wednesday or Friday, I don't remember, someday I am going to come to SSM Nagar. Whenever I am going to come to SSM Nagar, I am going to come 2 days to SSM Nagar. Those 2 days, I am going to teach you the fluids remaining part, or if any other chapter, if you want waves oscillations, I will teach, no problem, but in the offline section. Same way, to Perangathur people also, I am going to meet offline, like yesterday we met Satish sir, isn't it? Same way, you are going to meet me also offline. During that offline class, I will be teaching you your requested topics. Like fluid I will finish, if you want waves, I will teach waves, no problem in that. You can demand, I will take. But in this class, this online session, whatever schedule we gave to you, it will follow the same schedule. You may think fluid mechanics was written there. Misprint it was. It was not fluid mechanics today, because if I cannot take fluid mechanics in one day. So today we will start with thermal properties of matter. As the class goes, we will continue from here. Thermal properties of matter 2, thermodynamics 1, thermodynamics 2, KTG, waves, oscillation, then once again revising all the major parts of the syllabus, that is for the entire 11th syllabus. So, if you be in the program till February 14, you will feel that all your concepts are once again revised. I am going to revise right from units and dimensions, kinematics, laws of motion, work energy and power, rotational mechanics, everything. If you have in your final examination all the chapters, it will be benefit for you. Even if not, and you are trying to write NEET or JEE in the future, it will definitely help you. Okay. So this program is a separate program. Don't think it is normal regular class how I am taking there. Though we have tried to make the best interface for you, so that it's your choice. You can come for offline class, you can join online class, and I think online class will be as effective as offline, because it is not just taking from the system. You are seeing how much setup we have made. So the online class also will be as effective as offline class, where you can interact with me, you can speak to me, you can ask your doubts. And once again, I want to say to all the people who are there in the online that whenever you have any difficulty in understanding, don't hesitate, stop me then and there itself, or mute yourself and say, excuse me sir, I have a doubt. No problem in that. Let it be like normal class. And offline people, you know how to behave. No problem in that. Some rules and regulations, some basic things I want to say you. All of you know about video being on. It should be always on, because see, I am not going to monitor. They know I am standing in front of you. There is a console room. There they are monitoring. They are sitting and seeing everything. If they see your videos off for some time, they will prompt 2 times, then they will remove you. So people who have joined online, don't think we are not monitoring you. You are being monitored from the console room. I am not monitoring you personally. I cannot make you inside or make you go outside. So behave yourself in the online class by making your video to be on, and they have an eye on you, where you are seeing, to whom you are talking, what you are eating, everything. And the people who are sitting here, you, whenever you come for this class, carry water bottle with you. Don't make the water to fall down, but carry water bottle with you, because 2 hours of class, first class you are understanding, you will feel why I have said this. Up to 9:50, 9:20 it will go, you will feel exhausted by the end of the 9:20. That time you should have water. I will not leave you in middle. Get locked, that's all. I am going to put the curtains, you cannot go out. So once the curtains is put, red light is on, you cannot move out of the room. The class goes continuously for 2 hours. So please make sure that from next class you carry your water bottles. Don't carry anything to eat here. Eating strictly prohibited in this classroom. Anyhow, somebody will be there to monitor that, but I am once again saying to you, chocolate, toffee, anything, don't carry here. Not allowed to eat in this room. Okay? And again I am repeating that when you are coming to learn, come with the interest to learn, ask your doubts, make things clear. Don't simply sit for the namesake, online as well as offline. Because those who know me how I teach, if I teach to you, it is not only for your school exam, I am teaching beyond that also. I refer and say this question, this kind of thing can come in NEET, this kind of thing can come in JEE, so whatever. We name this class as concept strengthening class, which starts from today, where we want you to have your basics very strong. And those who have, like some of you are coming for the Sunday program, it will definitely help you there also. Fine, I hope the things are clear. And those who want to join offline, you can come offline, no problem in that. Those who want to attend online, they can attend online, no problem in that. But offline class happens only in studio, so you have to come to studio. So that is the only difficulty which you may have. So let us start the class today with all this basics, do's and don'ts. Let us start today's class. And you can put the heading in a notebook. All of you, those who are in online and those who are sitting here, give the heading in a notebook as thermal properties of matter. The heading is thermal properties of matter. Joel, remove your hand, leg, mouth, whatever you have kept on the camera. Yes, yes. Finger should not be on the camera. No, yes, good, Joel. Right. So coming back. So I was saying the heading is thermal properties of matter. So before this, we had 2 chapters in volume 2. The first chapter in volume 2 was mechanical properties of solids. Am I right? The second chapter in volume 2 was mechanical properties of fluids. And now you are learning thermal properties of matter. Matter means solid, liquid, gas, that is fluids as well as solids, everything together, isn't it? So in the first chapter, it was purely for solids, where you learnt about stress, strain and all these things. Am I right? Poisson's ratio, Young's modulus, bulk modulus, shear modulus and all this stuff. In the case of second chapter, you learnt about the mechanical properties of fluids, for example, viscosity, surface tension, pressure, transmissibility, Pascal's law, Bernoulli's theorem, capillarity is yet to be taught, capillarity is there. So these kind of properties are of fluids which are mechanical properties. In this chapter, we are going to talk about the thermal properties of matter. It means solid, fluids together. This chapter, what you are going to learn, I am just giving a brief about that. This chapter is basically having 2 parts. One is called as thermometry and second is called as calorimetry. Okay. So in thermometry, you will learn about the measurement of heat, and in calorimetry, you will learn about, in thermometry, you will learn about measurement of temperature, and in calorimetry, you will learn about measurement of heat. So this itself makes us to think that what is the difference between heat and temperature. So first, leave temperature. First, if I ask you, what is heat? When I say the word heat, what comes to your mind? When I say the word heat, what comes to your mind? Yes. Hemant.
Increase in temperature.
Loudly.
Increase in temperature.
Increase in temperature. Very good. What is your idea, Advait?
Same.
Increase in temperature. Karthik, what do you think? Same. Anybody else who has some other answer? Anshul, what do you think about heat? When I say the word heat, what comes to your mind? Fever. What, what comes to your mind? Tell me.
Same.
Same. Increase in temperature, isn't it?
Same.
Abhinand, what about you, man? If I say the word heat, what comes to your mind?
Change in temperature, sir.
Oh, change in temperature. Very good. Fine. So, Sharan Ram, you have anything to say here? What is heat? Form. Whatever you want, you can say, man. Right, wrong is secondary. What is heat? Layman's language. You're nothing. You don't know anything about school topics. Tell me, what is heat? Heat means what? Sood, we say in Tamil, right? For heat. Yeah, if I am right, I am not that good in Tamil, but whatever. So, first of all, from our childhood, we have been using this word heat for hot. Understand that heat and hot are not same. Heat can even be cold. Understand what I am trying to tell? Heat is not hot. Heat is the energy. Okay? It is the energy which creates a sensation of hotness or coldness inside your body. Okay. Suppose if I touch a boiling water, the vessel of boiling water, how do I feel? I feel hot, isn't it? I feel hot. Why, you know? Why I feel hot? You will say because it is at more temperature. Layman's word. Think more technically. Because energy is coming inside your body. That's why you are feeling it is hot. If I touch a pan which is burning, I feel it is hot because energy is getting transferred to your body. Touch some cold water, you feel it is cold. Why? Because the heat is going from your body in that body. If I touch ice and if it is cold, you know why? Because the heat is getting transferred from your body to that ice. Ice starts to melt, gaining energy, and you start feeling cool because your body is losing heat. So if body is gaining heat, it is hot. Body is losing heat, it is cold. Body may do both. One more example I'll give you, one very relevant example I'll give you. Suppose if somebody has fever, okay, you touch them, how they feel? Hot. Because they are at a higher temperature. When you touch them, the heat starts flowing from hot body to cold body. This is the equilibrium. Always heat flows from hot body to cold body. So when you touch somebody who is having fever, you feel they are hot because energy is coming to your body, isn't it? Suppose he is having fever 101 degrees Celsius. You are also having fever 101 degrees Celsius. One person has a fever 101 degree. You are also having fever 101 degree. Now you touch him, you will feel normal. Nothing, no fever. Because both of you are at same temperature, exchange of heat will not take place. You will feel he or she is normal. You are at 103 degrees Celsius. Now you touch him 101 degree. You will feel cool. What, man? You are cool. You are not hot at all. Because you are at higher temperature, that person feels to you as a low temperature, so it is cold for you. Because you are giving heat from your body to him. One more example I'll give you. Relevant example. Think. When the temperature is 30, 40 degrees Celsius in Chennai, you feel very hot, isn't it? When it becomes 17, 18 degree, leave 5, 10, 20 degree it becomes. Now it is 21, 22 degree only. You start feeling chillness. 20 degree, you are feeling it is cold. Are you feeling or not? If a person who is staying in Antarctica, okay, he comes at 20 degree, you know how he will feel? I am in oven. What is this very hot temperature? A person 6 months stayed in Antarctica, came to Chennai in rainy season, where temperature was 17 degrees Celsius. If he is sitting, no, he will say, what is this 17 degree, very hot climate. And same 17 degree you will be shivering. Once again, the reason is he is used to lower temperatures. Are you getting my point? So heat, first of all, be very clear, write the definition of heat. Heat is a form of energy. It is a form of energy transferred between bodies due to difference in temperature. Heat is a form of energy transferred between the bodies due to difference in temperatures. Everybody please take the notes properly. Whenever I want, I will check your notes. So have your notes well. The one who has joined with a dot, please put your name. Somebody is there without video on, it is in dot. to sometime if they are not unmuting and on in the camera, then you can remove them in the group. The dot person will be removed if you are not on the camera or putting your name at least. Nothing we know about you. Okay. I hope you wrote the definition of heat. Fine. So always remember, as I told you, write this. Heat energy always flows from a body at higher temperature to a body at lower temperature. You can write this also. As I told you now, that heat always flows from where to where? Higher temperature to lower temperature. I hope you wrote this. Okay. So now let us talk about temperature. Heat you told. Yes,
Sir, can you please go to the previous slide, sir?
I'll go.
Thank you, sir.
Make it fast, make it fast. Don't be slow in writing. If you sit behind this, will it be fine? Same only. Sit there then.
Completed, sir.
Completed? You are fine with it?
Yes, sir.
You also go back. Then go back, go back. Okay, now my question to you is, what is temperature? Lokita, if you are able to hear me, can you tell me what is temperature? Lokita? I asked something, Lokita. If you are hearing, please lift it. Yeah.
It is a fundamental physical quantity with which we can measure.
Measure what?
What can we say?
Measure distance, measure velocity, measure pressure.
Still, the difference whether it is cold or hot, like.
Okay. Okay.
But heat itself is in temperature, so you can't define temperature.
Heat is sensation of hotness or coldness. I said no. Heat was sensation of hotness or coldness. If I talk about temperature, it is the degree of hotness or coldness. Are you getting? Sensation of hotness, coldness is by energy. But degree of hotness, coldness is the measurement of temperature. That is measurement of the how much energy came. So write the definition of temperature. It is defined as degree of hotness or coldness of a body. So what is temperature? It is the degree of hotness. How much you are hot or how much you are cold. That is measured by temperature. So it's a measurement of degree of hotness or coldness. I hope it is clear to you. Measurement of degree of hotness and coldness of a body. You can also write this if you want to write. It can also be defined as thermal condition of a body which determines its ability to transfer heat to other bodies. Obviously, if a body is at 50 degree, if a body is at 20 degree, you can say the body will flow from 50 to 20. How you came to know? After knowing its temperature. So you can write it is also defined as the thermal condition of a body which determines its ability to transfer heat to other bodies. So temperature only helps you to know whether it is going to flow from which body to which body. I hope you have copied this. Done? Make it fast. Pratap, you want to say something?
Sir, I wanted to give the definition of temperature, but
Got it?
already given, sir.
Okay, okay,
Yes,
okay.
sir.
I hope you have copied, everybody. If you allow me, I'll go to the next slide, next page. Shall I? Okay. So now let us talk about thermometry first. I said you this chapter is two parts. One is thermometry, less important, less weightage, so it is simple to learn. Less important, less weightage of marks, so it is simple to learn thermometry. And then we will talk about calorimetry, where you will have all the problems. Okay, but if you understand thermometry, no, thermometry is very interesting thing. If you understand thermometry well. Okay, first let us talk about calorimetry. I said first we will talk about thermometry. So thermometry, I said you, it is a like branch of thermal properties where we learn about the degree of hotness or coldness. So if you see this, the first line that is mentioned here, if two bodies are at same temperature, then they will be in thermal equilibrium. I said you, if one thing is hot, one thing is cold, only then there will be a flow of heat. If the two bodies are at same temperature, then they must be in thermal equilibrium, isn't it? So see the second point, temperature is a macroscopic property of a body or a system. Why I am saying macroscopic? Why not microscopic? Because it is having a bigger value. And you see this, it is a physical quantity. So you can write this temperature, wherever you wrote temperature, you wrote temperature is a physical quantity. Please mention that temperature is a physical quantity, which is a scalar quantity, sorry. Temperature is a scalar quantity and it is fundamental, obviously. Temperature is fundamental and it is a scalar quantity. See, need not write everything from the board. Whatever I say, you can write those things alone. Fine. So now, after talking about temperature and heat, if it
Can you go to previous slides, sir?
nothing to write fully, Ranjit, there. Just you write from here that temperature is a scalar quantity. Nothing else is required from this slide. Other things you can know. Everything need not to be written. Okay, if you want to, you can write. Can I proceed, Sanjit?
Yes, sir.
Okay. So we were talking about, just let us summarize the difference between temperature and heat. So obviously temperature is the condition that determines the direction of heat flow, and heat is the energy transferred from higher temperature to lower temperature. See, second point is very important. Temperature is the average energy of the particles, heat is the total energy of the particles. One more thing I can say, heat is the cause and temperature is the effect. Since there is hotness or coldness, you have change in temperature, isn't it? So the cause is heat and the effect is temperature, not mentioned here. So third point is heat is a form of energy and temperature is the degree of hotness or coldness, and obviously heat is measured in joules or calories, whereas temperature is measured in Celsius, Fahrenheit or Kelvin. You can write this difference between temperature and heat. It comes sometimes in examination. Sometimes for 2 mark question they are asking this. What is the difference between heat and temperature? So you can note it down. Main points are the average energy of the particles is temperature, total energy is heat, and one thing which is not mentioned here is, you can write heat is the cause, temperature is the effect. Heat is the cause and temperature is the effect. You can add that point also, and the units of both of them. That is, temperature is measured in degree Celsius, degree Fahrenheit and Kelvin, whereas heat is measured in joules and calories. Let me know if you have copied. Yes, Gokul, you can ask me. Completed, you're saying that?
Sir,
Yeah.
sir, I'm connected in mobile, sir, but I don't get the server properly. Can
Okay.
I change my gadget, sir? For
Okay, join fast. Don't take too much of time.
okay, sir.
Hmm. Please ask me.
So why are there like three units for temperature? Why
See,
is it in why
mhm.
it isn't only Kelvin? Because it's the SI unit.
Tell me, what are the different units of distances?
Meter, centimeter, foot,
Kilometer, isn't it? Millimeter, decimeter.
kilometer, yeah.
But what is the SI unit of distance? Length,
Meter.
meter. Then why do we have centimeter, foot, and inch, all these things?
Convenience.
The same thing. See, SI unit was formed during 1900s after there was a big meeting held in Geneva, which was in which all the big people, that is scientists, came together and gave international system of units. You call it as Systeme di Internationally, SI. Before that, different countries were using different units. For example, if in India we are using meter, in some other place they were using foot. In India itself, if you go to South India, North India, East, West, everywhere they are using different units. After a long period of time, because there were confusions happening when we were transferring data from one country to another country, we came to a conclusion that let us form a SI unit of system. Then only Kelvin was chosen as the SI unit. Are you getting my point, Pratap?
Yes, sir. Yes.
Not only for temperature, for all the physical quantities, we have various units, but there is only single SI unit. So Kelvin is chosen as SI unit. If you ask me why Kelvin, why not the degree Fahrenheit, we'll talk about that now.
Yes, sir. Thank you. Thank you very much.
Okay, okay. I'll continue. So now, I hope all of you have copied the
Sir,
from.
can I say the last points you said, sir?
I said heat is the cause and temperature is the effect, which is not mentioned in this table. For heat you can write it is the cause, and for temperature you can add one point, it is the effect. It is not mentioned in the table here, but you can write by yourself. In heat you can write it is the cause, and temperature you can write it is the effect. Written? I hope you have written. Yes. So now, whatever is studied in the last 15-20 minutes, let us take a small quiz from you, shall we? So this question is for Sai Rakshana. Sai Rakshana, hearing? Don't leave the meeting. Unmute. Say hi, hello, anything, something. Yeah. Don't say, sir, my microphone not working, all this. I don't want to hear all this. Tell the answer for this. Heat is a form of energy transferred between two bodies due to difference in energy, difference in temperature, difference in mass, or difference in A and B. Sai Rakshana, you will try the answer. Others also can think, but answer should be told only by Sai Rakshana. I'll give chance to Vinand. Loudly, temperature. Okay, everybody agrees to this? Yes, obviously. Heat is a form of energy transferred between two bodies because of the difference in their temperature. Good. Next question is for Pratika, sitting here. Why not? Offline people cannot get questions. You also can get. When two bodies have same dash, they are said to be in thermal equilibrium. God, what kind of question they should not. When two bodies have same temperature, once again temperature is the answer. Today's hero is temperature only. So when two bodies have same temperature, they are said to be in thermal equilibrium. Good. So now this question is for Shweta sitting here. Shweta Shinde, not for you. Shweta who is sitting here. Shweta Karthikeyan, right? Yes. Temperature is physical quantity. Vector, scalar, fundamental, both A and C. Both B and C. So don't say answer before it will see the options. Scalar is true. Fundamental. So answer is D. Before the answer came, you said no, scalar. Scalar as well as fundamental, isn't it? So both B and C. I hope all of you are clear up to here. Now, let us talk about the measurement of temperature. An important thing now. This from here questions come. So if I ask you, let me open the, yes. This question is for Nitish. Nitish, hearing?
Yes, sir.
Yes. If I ask you, 20 degrees Celsius is how many kelvins? Can you say? 20 degrees Celsius Very good. Tell me.
292.
293. Very good. Correct. Because 273 is 0. So 20 will be 293. Very good. Bhumesh, if I ask you 30 degree Fahrenheit is how many Kelvin? What will be your answer, Mr. Bhumesh?
Don't know, sir.
Very good answer. Kirti, any idea? 30 degree Fahrenheit is how many Kelvins? Okay. Fine. Anybody who is sitting in the class can tell me the answer for this? Anybody who can remember the formula of how to convert degree Celsius to degree Fahrenheit at least? This conversion?
9/5, sir.
9 by 5 only is enough.
Or 5/5.
Multiply by 9 by 5.
5C plus 32 degree.
9 by 5 C plus 32, 5 by 9 F minus 32, all this is confusion, right? Definitely it is confusion. Do you agree with me or not? Yes. So now, after this thermometry topic, all of you will be able to remember forever how to convert one unit into another unit. Again, if you pay attention. If you pay attention for another 10 minutes, I am going to teach you the method by which you can remember any unit conversion from degree Celsius to Fahrenheit, Fahrenheit to Kelvin, Kelvin to degree Celsius. There is fourth scale also, I have not given in here, in competitive exam it is there. Fourth scale is called as Reumer. Apart from degree Celsius, degree Fahrenheit and Kelvin, we have a fourth unit of measurement of heat, which is called as degree Reumer, R, capital R. That also I will talk if time permits. So, first understand that for any thermometer, there are 2 points. One is called as lower fixed point, another one is called as upper fixed point. Suppose I am having thermometer this thermometer will have 2 points. One is lower fixed point and above you have upper fixed point, right? Every thermometer will have this. What is the meaning of lower fixed point? Lower fixed point is generally taken as the freezing point or the melting point of the ice. What is that? Melting point of ice or freezing point of water, whatever. 0 degree Celsius.
0 degree Celsius.
And upper fixed point is how much? Boiling point of water. Okay, if I ask you, define boiling point from your 9th standard. If I ask you, define boiling point, how will you define, Mr. Joel, Gladwin Joel? Without leaving the meeting, tell me. How do you define? What I asked the question? Boiling point, yes. Mr. Gladwin Joel? Yeah, what is boiling point?
No, sir.
Don't know boiling point. What is?
Boiling point, 0 degree.
0 degree, he will boil the water. This boy, you have the capability, man.
No, sir, no, sir.
Boiling, man, boiling, hot.
100 degree.
Okay, my question is not that first of all. Niranjan, which school you belong to, man, Niranjan?
SRM Public School.
SRM Public School. Niranjan, you tell me, how do you define boiling point?
That's the point, the temperature at which a liquid boils.
Very good. Temperature at which liquid boils is called as boiling point. Okay. Avanish, whether you agree with what Niranjan has told from SRM Public School? Sriniketan Avanish, you agree with him. Very good. LW Anshul, what is your opinion? Whether what Niranjan says, it is the temperature at which the liquid boils. Is he correct? LW Anshul, I am talking to you.
Oh, sorry, sir.
Tell me.
No, it's not fully correct. It depends, like, all the material, all the molecules in it today have to be boiled.
So you.
Reach to the point of.
So boiling point is the point where all the molecules start boiling. Can I say like that, Anshul?
Yeah, I mean,
Okay, I'll come back to you. Yes, Mr. Urapakam Sai Nikhilesh. Which school you are? Neelan matriculation. Yes, Sai Nikhilesh. Sai Akhilesh. What is boiling point?
Boiling point.
Amadda, boiling point.
The boiling point is the temperature at which liquid
get converted into gas, sir. But if we heat the liquid for too much also, it will remain in 100 degrees Celsius until all the molecules get converted into gas, sir.
You went too much deep. I wanted to tell you what is boiling point. What you will write, 1 mark question, define boiling point. What will you write? All these things you will write.
No, sir.
Or you will write like Niranjan. Niranjan will write the temperature at which liquid boils is called as boiling point. Okay, okay. I'll come back to you. Shweta Shinde, yes, from Wales Public School, Wales Global, whatever school. Yes. Tell me.
So boiling point is is the temperature at which the liquid starts changing its form, changing the state, physical state.
See, if the examiner wants to pass you, he will give marks for these things. Okay, whatever you people are saying, all of you, whatever you are saying, you will get marks for this answer if your teacher is having some mercy on you. Okay, failing by 1 mark, put mark for this question. But reality is, it is not whatever you are saying. It is not the point at which liquid boils. It is not the point at which liquid is becoming from liquid to gaseous state, nothing like that. The correct, you have learned in 9th standard, I'll say down, you will remember. I'll say, boiling, anybody can say? Boiling point is the temperature at which the liquid and the gaseous state exists simultaneously. Remember that. At 100 degree you can have water also, at 100 degree you can have gas also, vapor also. So how do you define boiling point? In 9th you defined this. It is defined as, in 9th chemistry I think, in 9th chemistry it was there, boiling point is defined as the temperature at which the, write somewhere, liquid and the gaseous states coexist simultaneously.
Coexist.
Yes, exactly. Same way, if I ask you what is melting point, you will say it is the temperature at which the solid state and the liquid state coexist simultaneously. What is boiling point? Temperature at which liquid state and gaseous state coexist simultaneously. If it is liquid and gaseous coexisting simultaneously, it is the boiling point. If it is solid and liquid state existing simultaneously, it is melting point. I hope it is clear now. Please at least now don't forget it. Tomorrow once again if I ask, you will say, sir, boiling point is liquid at temperature at which liquid is boiling. Don't say like all this. You are now in 11th standard. Some of you are going to appear for NEET JEE also. So don't write like this, please. Boiling point is the temperature at which liquid and gaseous state coexist simultaneously. Okay. I hope all of you have written this. Now coming back to this thermometry. So I was talking about there are different scales, and for each scale you must know the lower fixed point and the upper fixed point, which are the melting point and the boiling point. So if I go to the degree Celsius scale, I hope you know degree Celsius scale, what is the melting point? Degree Celsius melting point 0, boiling point 100, isn't it?
100.
So if you see, why not required, not required, not required, not required, yes, they have talked about ice point, melting point, yes. Now first Celsius scale, please pay attention. So what is the lower fixed point? 0 degree. What is upper fixed point? 100 degree. So what will be the number of divisions? Obviously 100, 100 minus 0 is 100. That is for degree Celsius scale. Same way, Fahrenheit scale. What is the lower fixed point? Anybody remembers? 30? Very good. What is upper fixed point? 290. 212. It came first. What is this here? Yeah. Ice point is 32 degree and the boiling point is 212 degree. So what will be number of divisions? Subtract both. 212 minus 180. So number of divisions in case of Fahrenheit 100, and remember this, in degree Celsius lower point 0, upper point 100. In degree Fahrenheit scale lower point 32, upper point 212, number of divisions 180. Same way, if I go for which scale now remaining? Kelvin scale. If you go to Kelvin scale, then Kelvin scale has a lower point of 273.15 exactly, 273.15 Kelvin. Actually, it is wrongly written as degree for it's a printing mistake, typing mistake, not printing. So it should not be degree Fahrenheit, it should be Kelvin, okay. 273.15 Kelvin, 373.15 Kelvin. So what is the number of divisions here? Once again, 100, isn't it? So in the case of degree Celsius scale, the lower fixed point is 0, upper fixed point is 100. Degree Fahrenheit scale, lower fixed point is 32, upper fixed point is 212. In Kelvin scale, lower fixed point is 273.15, upper fixed point is 373.15. So number of division in degree Celsius is 100, number of division is degree Fahrenheit is 180, and number of division in Kelvin is once again 100. Do you agree with me? If this much you remember, no, then any conversion you can make. Okay. And once again, now the answer for the Pratap's question, he asked me like why we take Kelvin scale as the SI unit, Kelvin as SI unit. I will tell you why we take Kelvin as SI unit, because Kelvin is the scale which actually first measured what is the lowest temperature possible. You know what is the lowest temperature possible? Lowest temperature ever possible is how much, you know? We can have minus 2 written here actually, yeah. That is called as 0 Kelvin. It is called as 0 Kelvin. Kelvin is the starting of temperature. First is 0, then 1, 2, 3. There, Kelvin can never be negative. If you are getting answer as minus 220 Kelvin, your answer is wrong. Kelvin can never be negative. Kelvin can only be 0 or above 0. What is the meaning of Kelvin scale being 0? It means that at that temperature, the molecular motion of the material stops. See, what is the meaning of heat? If it is having some temperature, the molecules will start to vibrate, isn't it? If the vibration of molecule itself is not there, it is coming to rest. What can be anything below that? Are you getting my point? If you are having an object at 273 Kelvin, it is having some vibration. You make 173, vibration reduces. You make 73, further reduces. You make 10, very slowly it is moving. You make 0, it stops. It is meaningless to say that Kelvin has gone in negative, because at 0 itself all the molecular motion stops. That is called as absolute 0. So what is the meaning of absolute 0? Absolute 0 means temperature at which all the molecular motion stops in a matter. Any matter will not have any molecular motion at 0 Kelvin, and this is called as absolute 0. And that is why Kelvin scale is also called as absolute temperature scale. Okay. From Kelvin only we take a reference and say that in degree Celsius it will be minus 273.15. So what is the lowest temperature possible? Minus 273.15 what? Degree Celsius. Okay, if you ask me in Fahrenheit, we will talk about that now. So up to here things are clear. All the upper fixed point, lower fixed point is clear to everybody. Number of divisions, I hope it is clear to everybody. Now I am going to talk to you about how to convert one system of unit into another system of unit. So please pay attention and listen to me very carefully. I said you, for any scale, you should know the 2 points. So I am drawing 3 scales here. One is degree Celsius, second is degree Fahrenheit, and third is Kelvin scale. This is degree Celsius scale, degree Fahrenheit scale, and this is Kelvin scale, right? Just now I said for any scale you must know its lower fixed point. You must know its upper fixed point, lower fixed point, lower fixed point and upper fixed point. Now in degree Celsius scale it is 0 degree Celsius and 100 degree Celsius. In degree Fahrenheit scale it is 32 degree Fahrenheit and 212 degree Fahrenheit. In Kelvin scale, it is 273. 273.15. I will write once again. If I put this, everything will get erased. I am writing 273. Leave 0.15 as of now. 273 Kelvin, and this will become equal to 373 Kelvin. You also know the number of divisions between them now. Number of divisions in degree Celsius scale is 100 divisions. Number of divisions in Fahrenheit is 180 divisions, and number of divisions in Kelvin scale is 100 division. Now, the relationship between all these three types of unit is, let me write here, temperature in Celsius scale minus lower fixed point divided by the number of divisions, obviously in Celsius scale, must be equal to temperature in, or I should write like this, temperature in first scale minus lower fixed point is equal to temperature in second scale minus lower fixed point divided by number of divisions. It means if you want to convert degree Celsius to degree Fahrenheit, you know what you will do? You will write temperature in Celsius divided by minus 0 actually, divided by how many divisions are there? 100. That will become equal to temperature in Fahrenheit minus 32 divided by how much? 180. This will also be equal to temperature in Kelvin scale minus 0 divided by, not 0 actually, it is 273. 273 divided by 100. I hope you are getting my point. So, these are the relationship between different scales. By this relation, if I am giving Tc to you, you can find Tf. If I give Tf to you, you can find Tk. If I give Tk to you, you can find Tc. Anything you can find. Are you getting what is the formula? Formula is temperature in Celsius scale divided by 100 is equal to temperature in Fahrenheit scale minus 32 divided by 180 is equal to temperature in Kelvin scale minus 273 divided by 100. So, all these things have come from what? By knowing lower fixed point, upper fixed point and number of divisions. If you understand this, then any conversion is possible by this concept. I hope all of you are understanding what I have told. If you put here Celsius value, you can get the corresponding Fahrenheit value. If you put Fahrenheit value, you can get Kelvin value. Put Kelvin value, get Celsius value. Whatever value you want to get, you can get from here. This formula is the mother formula of all the conversions. Any scale, if you get a new scale also, you can use this formula. The only thing is you should know the lower fixed point, upper fixed point, and then obviously number of division will be subtraction of both. Clear? Copy this, I will give some questions now. If you have understood this, copy this fast. I will give you some numericals now. I hope it is clear to everybody whatever I have told up to now. Can I erase the board? If you permit me, I will erase the board. Can I erase the board?
Yes, sir.
Thank you very much. I think nobody has problem in this because once I erase it, it cannot be reverted back. This page cannot come back. This is not a document, this is my writing, so it will go off if I erase. Parshika, shall I erase? Okay. Now, so whatever I spoke now, if I just formulate, is the same thing here. Unknown temperature minus the ice point is lower fixed point by steam number of division only. So, if you see this formula, Tc minus 0 by 100 is equal to Tk minus 273 by 100 is equal to Tf minus 32 by 180. By this formula, you can do any conversion from any particular value to any other value. You can easily convert if you understand this formula. Is it clear to you? Sure? If yes, then now tell me the value of absolute 0 in degree Fahrenheit scale. what is the value of absolute, question to everybody, online, offline people, everybody. The question is, determine the value of absolute 0 in degree Fahrenheit scale. That is, you have to convert 0 Kelvin into degree Fahrenheit. What is the value? You have to convert 0 Kelvin into degree Fahrenheit. Make it fast. Question is convert 0 Kelvin into degree Fahrenheit. Tell me the value. This is the question.
You want an answer in Fahrenheit, is it?
Yes, yeah, that only I have given in the question.
4.7 degree Fahrenheit.
4?
4.7 degree Fahrenheit.
4.7. Properly check. You have made mistake in calculation. How it can be, Lokita? You are doing this mistake. Unacceptable. Put 0 here. It will be minus 273 into 180 by 100 plus 32. Am I right, Lokita? Okay, you cannot take 0.15. Just take 4 plus 494.
So
Minus 494 is Karthik's answer. Anybody else? What is the answer you are getting? Anybody else?
Minus 387.4, sir.
Everybody have their own points. 494 is your answer, right? 492.
Minus 387.4.
See. Hearing, no?
Minus 449.4.
459.
Minus 457.2.
Everybody has their own answer. My God.
Minus 459.
Minus 449.4, sir.
Minus 4.
Minus 459.4.
That is the correct answer. Minus 459 is actually correct. Let us check, it will be mentioned. Yeah. Minus 459 is correct. If you are getting minus 459, that is only the correct value. Remember that. Oh, somebody is not. So minus 450. This,
3.4.
the answer I have written on the board here. Now you just check. If you are not getting, you are doing some mistake in calculation. If you do correctly, the answer will be minus 459. You have not taken 0.15, little bit here and there may be there. But it will be around minus 459 only. Please pay attention. The answer will be minus 459. And you can remember this. You can remember this answer hereafter. That absolute 0 is 0 Kelvin, minus 273.15 degrees Celsius, and minus 459.6 degree Fahrenheit. You should remember these things here. It's basic GK question. This is leave physics. Boiling point of water, freezing point of water, absolute 0. These things you should know. Absolute 0 is 0 Kelvin. In degree Celsius, minus 273. In degree Fahrenheit, minus 459. If you have got this, then your answer is correct. If you have not got this, some mistake you made in calculation. One more question I have for you. Calculate and tell me, at which temperature, question is at which temperature, all of you please take the question. Online people, write down. The question is, at which temperature degree Celsius and Fahrenheit read the same value? At which temperature?
Sir, minus 40.
Minus 40. Okay, let us check. Pratap says minus 40. He remembers, so he says minus 40. Check that. Question is, at what temperature the degree Celsius and Fahrenheit reads the same value? Pratap says it is minus 44. Sorry, minus 40 he said. Others, check. Shweta, you can mute yourself. I hope you are solving, Shri Avinash. Question is, at what temperature degree Celsius and Fahrenheit read the same value. So, how will you solve? X by 100 is equal to, yeah, x by 100 is equal to x minus 32 by 180. Get the value of x.
32 by 80, 180.
Yes, solve it and get the x value. X by 100 is equal to x minus 32 by 180. So, 0 0 gets cancelled, it will become x by 10 is equal to x minus 32 by 18. So, 2 5s are 2 9s are. So, it will become 9 by 5.
So minus 40.
Minus?
The answer should be very sorry.
40.
Minus 40. All of you got minus 40?
Yes, sir.
Exactly, you are getting minus 40.
Yes, sir. As the minus 8x is equal to 327 divided we get is minus 40.
Exactly, minus 40. Good, Pratap, you remember this answer. So, minus 40 is the temperature where degree Celsius and degree Fahrenheit will have same value reading. Are you getting? I hope thermometry is clear to you. Very simple. I said there is another scale not in the school exam, that is Reumer scale. Only thing is Reumer scale is having lower fixed point of 0, upper fixed point of 80. Over. Story is over. 0 80 means TR minus 0 by 80. That's all. Already we have seen TC minus 0 by 100 is equal to TF minus 32 by 180 is equal to TK minus 273 by 100 is equal to TR minus 0 by 80. The fourth scale is called as Reumer scale, where the lower fixed point is 0, upper fixed point is 80. So, number of division will be 80. I hope you are understanding this. Not required for school, by the way. Okay. So, if we proceed further, this is all about thermometry, simple thermometry, isn't it? Thermometry is a simple concept. The question is here. Question is for Shriya Vinash, offline Shriya Vinash from SSM school. Water boils at 373.15 Kelvin, 100 degrees Celsius, 212 degree Fahrenheit, A, B and C. Oh, guessing only, no? Very good. Actually, it is correct guess. Boiling point of water is 100 degree, 373.15, and if you convert in degree Fahrenheit, it will be 212 only. So, 212 is the correct answer. So, answer is A, B and C. Your luck has worked. Okay. Next, the question is for Nikas. Nikas of Sriniketan, right? No. Yes or no? Nikas of Sriniketan. Unmute yourself, man. Class itself will be sleeping only. Yeah. So, this question, melting point of ice. Simple, man. 0 degree, 273 Kelvin, 32 degree Fahrenheit, all of these. Mr. Nikas, melting point of ice is 0, 273, loudly. Tell me again, Nikas.
Sir, yes, sir.
A. Okay, Avanish, you concur with him? You agree with what Nikas has said? Avanish, Mr. Avanish from Sriniketan?
Sir, I think it is all of the above.
Okay. Yes, obviously all of the above. Yeah, why you are thinking? 0 degree is 273, 273 is 32. So it is all of these only. Very bad. Nikas, be alert. Don't sleep in the online class. Okay. Now this question is for Ivan of SSM school.
Sir, 100.
Upper fixed point in Celsius scale is 100 degrees Celsius. Obviously, yes. So, let us talk about the next concept now. Shall we go into the next concept? I will not go to thermal expansion now. I will come to this topic later, today itself. But rather, I will spend my time today in talking about calorimetry. Just now I have taught you thermometry. Next, I will talk about calorimetry. Then I will come back to thermal properties. Today, I hope we will do this also. But first, now give the heading as calorimetry. Give the heading as calorimetry. Give the heading as calorimetry. Okay. And you write, it is a study of measurement of heat. It is a study of measurement of heat. Energy, obviously. Measurement of heat energy. Okay. So, for understanding calorimetry, the first topic you should understand is specific heat capacity. You give the heading as specific heat or specific heat capacity. Okay? Give the heading as specific heat or specific heat capacity. I think these things are there in chemistry also, or what? No? Yes? I think somewhere it should be there in chemistry also. I don't remember, but
Yes, sir.
it's
Thermodynamics.
thermodynamics. Very good. Then you should remember this. Okay. Anyhow, so what is specific heat capacity? Anybody is voluntarily ready to answer this question? It is given by the letter small c. Yes. Tell me.
The quantity of heat to raise 1 unit of substance by 1 degree Celsius or 1 degree Kelvin or by 1 unit degree Celsius.
Okay, good, good, good. It is the amount of independent of mass.
Independent of mass.
Independent of mass. Oh, surprising. Okay, write a definition. It is the amount of heat energy required. All of you please write. It is the amount of heat energy required. It is the amount of heat energy required to raise the temperature of unit mass of a substance of unit mass of a substance of unit mass of a substance unit mass of a substance by unit degrees by unit degrees by unit degrees. It means that if you have 1 kg of something, anything you can imagine, 1 kg of iron, 1 kg of copper, 1 kg of brick, 1 kg of wood, whatever it may be, if you take 1 kg of anything, and in this 1 kg of anything, if you are going to heat it, 1 kg of brick is there, I am heating that brick, its temperature is 27 degrees Celsius now, suppose. I will check how much heat energy is supplied to make it 28 degrees Celsius. That heat energy is called as specific heat capacity of brick. Understood this? If I am having 1 kg of copper at 40 degrees Celsius, I supply heat to it. I calculate how much heat energy is supplied to make its temperature to be 41 degrees Celsius. That heat energy is called as specific heat. Is it clear? It is the amount of heat energy required to raise the temperature of unit mass of substance. That's why I am taking 1 kg by unit degrees. Is it clear to everybody who is in the online also? How much heat energy is required by unit mass of substance to increase its temperature by unit degrees? That heat energy is called as specific heat or specific heat capacity. I hope it is clear. Clear? So, if I just write the mathematical form of it, so I wrote here, small c is how we denote specific heat capacity. So, specific heat capacity small c will become equal to amount of heat required, Q divided by how much mass into delta T. This is the formula of specific heat capacity, Q by m delta T. From here only we get heat energy Q is equal to m c delta T, which is m is the mass of substance, c is the specific heat capacity, and delta T is the change in temperature. How the questions will come from here? 5 kg of water, how much heat is required to change its temperature from 20 degree to 70 degree? I am not giving question to you, I am just giving you example. Please pay attention guys. Before you write anything, please pay attention. I am saying, if a question can come like, how much heat energy is required to raise the temperature of 5 kg of water from 20 degree to 70 degree, if they give the value of specific heat of water to you, C is they give, its value is 4200 actually. So, M is given as how much? 5 kg. C is given as how much? 4200. Delta T will be how much? 50, because 70 to 20 to 70 means 50. Put here, multiply, get the answer, that much joules. Some of you may have a doubt now, if you are listening carefully, you will say like, sir, temperature you are taking in degree Celsius, but SI unit of temperature is Kelvin. Is it right to take in degree Celsius? It is actually. You know why? Because 20 degree Celsius is how many Kelvin? 293. Okay. 70 degree Celsius is how many Kelvin? 343. 343 minus 293 will be how much? 343 minus 293 will be how much? 50. So whether you convert to Kelvin and reduce, or whether you directly reduce, since delta T is the subtraction of the two temperatures and the number of divisions in the Celsius scale and Kelvin scale are same, you are going to get same delta T. Are you understanding? I will repeat for some people. If T1 is given as 0, T2 is given as 20, subtract both, you will get 20. If somebody is subtracting in Kelvin, subtract, no problem. 0 means 273, 20 means 293. Subtract 293 minus 273, you are once again going to get 20 only. So whether you take in degree Celsius or you take in Kelvin, it is not going to affect your answer. I hope you are understanding this, isn't it? So this is about the specific heat capacity. I hope you are clear in this. So specific heat capacity is what? Specific heat capacity is amount of heat energy required to change the temperature of unit mass of substance by unit degrees. So the formula I have written here for the U, Q is equal to mc delta T, and delta Q is proportional to mass of body. Abhinand, you are saying that heat energy is not depending upon mass. It depends upon mass actually. Yeah, it will come next. So if I talk about the next topic, which is heat capacity, I hope you are clear in specific heat capacity now. Specific heat or specific capacity is given by small c, and that is delta Q by m delta T. Let us talk about heat capacity. In some books, they are also writing it as thermal capacity. Okay, I am repeating, heat capacity is also written as thermal capacity. Definition is there on the board. It is the quantity of heat required to rise the temperature of body through 1 degree. Here mass is not there. If mass is there, it is specific heat capacity. If mass is not there, it is just heat capacity. That's what he was saying. Abhinand got confused between mass, specific heat capacity and heat capacity. Yeah, no issues, no issues. I understood where you got confused. Specific heat capacity is amount of heat energy required to raise the temperature of unit mass of substance by unit degree. But heat capacity is amount of heat energy required to raise temperature of any body, not unit mass, by 1 degrees. Are you getting? So here it is mentioned, quantity of heat required to raise temperature of a body through 1 degree is called as its heat capacity. If it is specific heat capacity, mass is must. If it is not, then it is heat capacity. I hope you are clear in this. So what will be the formula of heat capacity? It was, in the case of specific heat capacity, it was Q by m delta T. Here m is not there, the formula will become equal to Q by delta T. Yes, here at writing delta Q, you can write Q also, no problem. Heat capacity will be Q by delta T. Specific heat capacity was Q by m delta T. Heat capacity will be Q by delta T. M will not be coming because it is not for unit mass, it is for any mass. I hope you are getting my point. Is it clear? These kind of questions will definitely come in the examination. Heat capacity, specific heat capacity, how they are different from each other. That is Q by m delta T. It is Q by delta T. I hope it is clear. So let me talk about this. Yeah, this relation you can find by yourself. Since H is equal to Q by delta T, it is delta Q by m delta T. If you relate both, you will be able to get H will become equal to m into C. Common sense. Specific heat will become equal to m into C. Write down somewhere. Full thing not required. Last point is important. That is, heat capacity is equal to mass into specific heat capacity. So if you are having specific heat capacity value, multiply by its mass, you are going to get its heat capacity. Let me know if you are done. Done? Sure? I hope it is clear. Okay. Now I want to ask a question to everybody. Coming 15-20 minutes, be very concentrated because I am going to talk about something very important. From here, expect a question to surely come in school examination, and in competitive exam also, whether it is NEET or JEE, one question may come from here. Which topic? I am going to talk about the principle of calorimetry now. Okay. So, before I talk about the principle of calorimetry, you should also have some idea about one more topic is there. Before that, one question I will ask you. See, suppose I am having a beaker. Okay. Everybody, please pay attention. Stop writing anything if you are writing Abhinand. Please pay attention. The question is, if you are having a big beaker or big jar, you are having ice inside it. Okay. What is temperature of ice? 0 degree, always 0 degree. It can be how much? It can be negative also. Minus 20 also it can be, 0 also it can be, minus 15 also, minus 100 also it can be. Ice can be anything below 0, 0 or below 0. Am I right? Let me assume that we have ice at minus 20 degrees Celsius. I hope all of you are listening very carefully. We have ice at minus 20 degrees Celsius. Okay. I keep that minus 20 degrees Celsius ice in a beaker and put it over a burner. High flame, very, very high flame, maximum heat. I on the flame. Inside the beaker, I also have a thermometer. Is the point clear? Beaker is there, ice is there, and I have 1 kg of ice and thermometer inside. How much thermometer will read before on the burner? Minus 20, because temperature of ice is minus 20. It will read minus 20, right? Okay, minus 20 ice reading. The moment I on the burner, what changes will you observe? No change means minus 20 will read minus 20. Why? Heat is applied, no? So you think it will minus 20 only it will be there till ice is melting. Okay, good. So what is your opinion, Shivaranjani? If you are hearing me, open your mouth and say that what you are expecting for this scenario. Karthik says that temperature will not change until all the ice is melting, it will remain minus 20 only. This is what Karthik says. So Shivaranjani, if you are hearing me, I want a reply from you.
Yes.
Yes. What will happen, do you think? On thermometer what will happen? To ice what will happen?
Don't have any idea.
Don't have any idea. Think and say a layman's question, not technical question. Ice is there. Ice is at minus 20 degree. You are owning a burner. Burner means what? Heat is there, right, Shivaranjani?
Yes, sir.
Okay. Now, what change do you expect in the thermometer and what change you expect in the ice? That is the question. Obviously, it melts. I'll come to you. Tell me.
It melts, and when thermometer, due to the difference in the temperature, the volume just expands, so it rises.
Very good. So, you went to volume expansion and all. Okay, good. So, you will see ice starts to melt and temperature will remain minus 19, minus 20, or it will become like minus 10, minus 5, like that.
Yeah, sir.
Okay. What is your opinion, Vatsal Bharadwaj? Vatsal Bharadwaj, if you are hearing me, I want to hear from you.
Yes, sir.
What you are expecting? Yes, tell me.
I think the temperature will increase in the thermometer, sir.
Okay. And ice will also melt?
Ice will get melt.
Okay.
Yes, sir.
Fine, fine. I get your point. Kirti, what is your expectation? Okay, you think the same. Leah Varshini, what is your opinion?
So the ice will melt and the temperature will rise in the thermometer.
Okay. Niranjan, what is your opinion?
Temperature will increase to 0 Celsius
and then the ice and then the temperature will stay at 0 Celsius until all the ice is melted.
Okay, Mike, once again I am coming back to you only, Niranjan. You say that temperature on the thermometer will start to increase. Will the ice melt that time?
Sir, the temperature will start at -20, then it will reach 0 Celsius, and it will stay like that until all the ice is melted.
That's what my question to you was. When the temperature was changing from -20 to 0, will the ice melt or it will not melt? I am giving a big
Sir,
heat
it will
here.
not melt.
Oh, so
It will not
so
melt.
you think like whatever heat you supply from the down, until the ice comes from -20 to 0, nothing will become water. It will remain ice cubes only. That's what you think, Niranjan. Am I right? Just say yes if you are saying what I said.
I have a doubt, sir.
Please tell me.
Sir, do you see this as a single object or like many items we have put together, sir? A single object, right?
You are thinking single ice or many ice cubes? That is your question.
It's actually gonna, yeah.
Okay, whatever you want to assume. You want to assume single ice, take single ice. You want to assume big, small, 100 pieces of ice, assume that. Your wish. Both will have same thing only.
When it won't melt until it is zero, sir.
Okay.
It goes to zero and stay as ice.
Okay.
And when it is at zero, sir, it start melting. The temperature won't change. It will be at zero.
Oh.
When it's completely melted to water, then it decreases again.
Decreases again.
Like from increases or increases. 1, 2, 3.
Why does that happen? If
Later heat fusion also.
loudly.
Later heat, sir.
Exactly. What Abhidand and Niranjan has said is actually true. The moment you will on the burner, even though heat is supplied from the burner, you will not see a single trace of ice melting. If you down have something to check water is coming or not, zero water will come. Until what time? Until the temperature is reaching from -20 to 0. The moment temperature comes to 0, ice starts becoming water. When ice starts becoming water, you won't see any change in the thermometer. Even though heat is there, supplied, it will remain 0 only. Surprising, but it happens. Because whatever heat you are supplying is being used to change the state of ice from solid to water to liquid. Are you getting my point? The moment all the ice becomes water, now once again temperature starts to rise. It will rise, reach where? 100. The moment it touches 100, whatever heat you supply, it won't change. It will remain 100 only. Water starts to boil. It starts becoming steam. If you have a closed container, it will become steam. The moment the whole water becomes steam, once again temperature will start rising on the thermometer. 100, 120, 140, 200, 300, 400. Steam can even be at 400. But water cannot be at 400. I am talking only about NTP and STP, that is normal temperature and pressure. If that is changing, something else will happen. I am talking about normal temperature and pressure. If you compare ice and water, if you compare water and vapor, you will realize that water cannot cross 100 degree. Vapor on the other hand can cross even 300, 400 degree. That's why it is said that steam is more harmful than hot water. If you get a burn by hot water, no, and if you get a burn by steam, steam will be more painful. If you get a burn by steam, that will be more painful than a burn that you get by a hot water. Because hot water will always be 100 degree only, or less, even less than that if it is not in the boiling state. But steam can be minimum at 100 degree. Are you getting my point? 100, 120, 150, 200, 300, 400 also it can be. If it is 400 degree steam touching your hand will, what do you say? It will, skin will come out of your hand. That much hot it will be. Are you getting my point? One thing what you are understanding from here is, there are two possibilities. Change in temperature and change in state. If temperature is changing, state will not change. If state is changing, temperature will not change. And just now what I have talked is that this property is called as latent heat. Latent means hidden, and latent heat means hidden heat. Are you getting? Which heat is not visible on the thermometer. I said no, when the ice becomes water fully, then until this ice is becoming water, you will not see any change in thermometer. You know why? Because that time the state was changing, temperature will become constant. When temperature was changing, I said you none of the ice will become water, because if temperature is changing, state will not change. If state is changing, temperature will not change. Remember this logic. A change in temperature does not change the state. A change in state does not change the temperature. So you should know what is the meaning of the word latent heat. I'll talk about that before I go to the calorimetry principles. So you write the next heading as latent heat, and you write please ask me.
Why, if the state changes, why will the temperature not change?
That is what is called as, if what you are saying, if the state is changing, when the state is changing, whatever heat energy you supply, no, it is being used to change the state only. Nothing is going to change the temperature. Are you getting a point? Whatever heat you supply, it can be used in two ways, either to change the state or to change the temperature. Both cannot happen simultaneously. That is the law of calorimetry. Are you getting my point, Kirti? So if there is a change of temperature, state will remain constant. If there is a change of state, temperature will remain constant. I hope you are clear in this. So first you write what is latent heat. You can define it is the heat absorbed or given out by unit mass of a substance during the change of state. You can add one more line here, without change in temperature. When you write in definition, the amount of heat as absorbed or given out by unit mass of a substance during the change of state, add one line here, during change of state, here you write without the change in temperature, without the change in temperature. Is called latent heat. And how it is defined, latent heat? Mathematically it is Q by M. So Q is in calories, mass is in gram, it will be calorie per gram, CGS unit this is, and if it is joule per kg, it is SI unit. And this is the value of latent heat of fusion of ice. How much it is? 3.35 10 to the power 5. And what is the meaning of latent heat of vaporization? At fusion means ice becoming water. Vaporization means water becoming vapor. Remember? What man? I think it was Shivaranjani, something you were saying?
No, sir, not that.
Yeah, you can say if you want to say something. So fusion means change of state from ice to water, and vaporization means change of state from water to vapor. So here it is ice to water. And what is vaporization? Water to vapor. I hope it is clear. I hope it is clear. Any doubt, you can ask me. If there is any doubt, you can ask me. Because now I am going to give some numericals to you. Is it clear? Can I go to the next page, guys, if you agree?
Yes, sir.
I'm erasing the board. Can I? Okay, thank you. So what we have come to know now, we have come to know that, okay, we have come to know that there are two possibilities. One possibility is change of temperature, and when that happens, there will be a constant state. And for this, the formula is Q is equal to mc delta T. Are you getting my point? If you are using the formula Q is equal to mc delta T, this will help you to find how much heat energy is required to change the temperature. Are you getting my point? From 20 to 40, you can put the value of delta T here. C will be given to you, mass will be given to you. So, this formula you can find how much energy is required to change the temperature without changing its state. Second thing is change of state. Change of state. And this happens at what? Constant temperature. So, if this is happening, then what formula you will use? You will use the formula of Q is equal to ml. If it is latent heat of fusion, you will use mlf. If it is latent heat of vaporization, you will use mle. I hope you are getting this. If you are using, there are two possibilities here. You may use mlf if it is fusion, or you may use mlv if it is vaporization. So, I hope it is clear to you, isn't it? How things are happening, it is clear to you? Yeah, tell me.
Fusion is equal to ml.
Who is speaking?
Anshul, sir.
Anshul, please tell me, Anshul.
So for the fusion, we have said that we have used the formula Q is equal to ml.
MLF.
Yes.
LF means latent heat of fusion and LV means latent heat of vaporization. Latent heat of fusion and latent heat of vaporization. Is it clear? I hope it is clear. Okay. Now comes the main part which I was talking. I said no, from here the numericals are always coming. Whether it is a competitive examination or it is a school examination, expect question to come from principle of calorimetry. And what is the principle of calorimetry? Understand the principle. Principle of calorimetry is very simple. It says that what is the heat gained by one body will be the heat lost by another body. It means that, see, if you have a guest in your home, leave guest, you are still going to your home, you are still guest only. When you go to your home and it is a hot day and you want to drink a chilled glass of water and there was no water kept in the fridge, how will you get chilled water then? Ice. You will take water, add ice cubes, enjoy the water. If cold drink is not there, cold drink is there, you will enjoy the cold drink, whatever. So, if you have water and if you add ice, water becomes cold. Why? Because you may say because ice is cold, so water becomes cold. Common sense, isn't it? Layman's language, what you will say? Ice is cold, water is hot. I added ice in the water, water became cold. But now you are learning calorimetry. How you should think? You should think like, the moment I added the ice in the water, ice was at lower temperature, water was at higher temperature. There is an energy transferred from hot object to a cold object. Who is losing heat? Water is losing heat. If somebody is losing heat, it will become hot, cold, no? So, water loses heat and ice gains heat. That is why ice melts and water becomes cold. If water is also at 1 degree Celsius, you add ice, it won't melt so easily. Why? Because water is at lower temperature, it will not be able to transfer the heat to the ice. Are you getting what I'm trying to tell you? If 0 degree water is there, add 0 degree ice, no change. Ice will remain ice throughout. Because only the change can happen when transfer of heat energy takes place. Are you getting my point? So when I am putting the ice into the water, there is a heat gained by the ice, and who is losing heat? Water is losing heat. Since water is losing heat, it is becoming cold. Since ice is gaining heat, it is melting. Are you getting my point? So this is what principle of calorimetry says. It says that, write this, heat lost by one body is the heat gained by the other body. That is, heat lost by the hot body is the heat gained by the cold body. I hope you have written this, important. Heat lost by the hot body is always equal to heat gained by the cold body until they attain thermal equilibrium. Until they attain thermal equilibrium. Obviously, we are assuming there is no loss of heat. In reality, there will be some loss of heat, but we are assuming there is no loss of heat. We are assuming there is no loss of heat. I hope you are getting my point. Is it clear to everybody? Up to now, whatever I have taught, is it clear to everybody? Because now you are going to face a numerical, a very simple one, very, very simple one. And if you solve this, you will get confident in the calorimetry principles. Shall I give the numerical? All the online people ready? Online people ready?
Yes. Sir.
Yes, please ask me.
Yes, sir.
Manoranjan, I am hearing you, please tell me. Mano,
Will the ice be sticky, sir?
will the ice be sticky means? You are talking about, you are asking me why the ice is sticky.
In some cases, the ice will be.
Sticky, yes,
No, sir, in some cases, the ice will be sticky, sir.
yes.
Sir, what is the reason for it?
Okay, you are asking why the ice is sticky sometimes. When you touch the ice, it looks sticky to you. That's what your question is?
Sir, when we.
Huh. Tell me.
Sometimes when we open the fridge and touch into the surface of the freezer, we feel it like sticky.
You are talking about sometimes when you are opening the freezer and there is some ice accumulated on the sides of the fridge, then what? Milk packet.
Sir, may I try?
Tell me, Pratap, what you are saying?
Sir, I can try to answer.
Yeah, try, answer, Pratap. Tell me what you are trying to answer. Tell me.
Sir, what is telling is that if you have a tray of ice
Yeah.
in the freezer
Yeah.
and our hands are wet,
Yes.
so if we place our hands on the ice, we feel like for a split second the ice are going to stick to that ice in the tray. Our hands are going to stick to the ice in the tray.
Yes. I now understood. Okay, so he is asking why it happens.
Yes.
Okay, you have any answer, Pratap? You are saying something?
Yes, sir.
Tell me.
That is because the amount of water in our hand is very low.
Okay.
So it can readily freeze or immediately freeze as we touch the ice because heat is lost immediately.
Okay.
So for that split second, the water in our hands will turn into an ice,
Okay.
and then so.
See, I'll tell you. See, it's good that you are thinking this much, but now please pay attention. The thing is, something like what he said, what I understood, Manoranjan, your question is, if you have leave ice tray, if you are having some ice and touch it, it will feel to you like sticking to your hand only. You can try this today also after going to home. I think there is no much physics involved in that much. More than physics, what involves here is more chemistry here. The ice will have some bonds, right? Water bonds will be there. Water will have some bond, right? Some covalent bond. Ionic bond, something is there. What is the bond in the water molecule? Covalent bond. Whatever, yeah, I am not that good in chemistry, whatever. So whatever bonds are there, when you are touching, the water bonds are actually sticking to your hands, dry hand. If you make your hand wet and try to touch, you will not feel that stickiness. Check. With a dry hand, if you touch the ice, you will feel that it is sticking to your hand, because the bonds of the water molecules, they are trying to bind with your hand. I think that can be one of the reasons why it is sticking. Anyhow, you can check more details about chemistry inside this. It's not much about physics, right, Manoranjan? Okay, anyhow, take the question now. Shall I give the question? Guys, I hope you are hearing me, all of you. Okay, then the question goes like this. Yes, question is, calculate the heat required. All of you please take the question. Calculate the heat required. Calculate the heat required to convert. Calculate the heat required to convert 3 kg of ice. To convert 3 kilogram of ice, 3 kg of ice at minus 12 degrees Celsius. 3 kg of ice at minus 12 degrees Celsius into steam at 100 degrees Celsius, into steam at 100 degree Celsius, into steam at 100 degrees Celsius. They have given specific heat of ice as 2100 joule per kg per Kelvin. I should write like this, that is better. And they have given the specific heat of water as 4186, exactly they have given, joule per kg per Kelvin. They have also given LF fusion 3.35 into 10 to the power 5 joule per kilogram, and LV is 2.25 10 to the power 6. What, Avinash? See behind you, above. What is there? Here, not when, here, see. What is there? Whatever is happening in the class is getting recorded, man. We are live. So you want to find the amount of heat required to convert 3 kg of ice at minus how much? 17, minus 12 into steam at 100 degree, and they have given all the values to you. Can you solve it? Give a try. I'll give you a hint if you are not knowing much. That first of all, minus 12 degree of ice will become minus 12 degree of, 0 degree of ice, isn't it? The Q1 will be heat required to change the temperature of minus 12 degree ice to 0 degree ice with no change of state. That will become equal to mc delta T. Then Q2 will be amount of heat energy required to change 0 degree of ice into 0 degree of water at same temperature. 0 degree ice, 0 degree water. What formula you will use? ml. Q3, amount of heat required to change 0 degree water to 100 degree water. What formula will use? mc delta T. And then finally you will find amount of heat required to change 100 degree of water to 100 degree of steam. What formula you will use? mlv. I told the answer itself to you. Add all the 4Q, get the answer. Q1 plus Q2 plus Q3 plus Q4 will give you the answer. Solve it fast. Q1 will be mc delta T, Q2 will be mlf, Q3 will be mc delta T, Q4 will be mlv. Just add these 4, you will get the answer. this chat option is there, no? If you come down, you come and scroll in this participant, you come scroll.
Actually, it came separately.
Yeah. Close this. Go to chat. If you go here, if you go to here, 3 clicks, not there, leave. There is below that. That, not this also. Something is wrong. Close it.
Yes, sir. Yes, sir.
Yeah. Participant can chat, no one you give. Actually, you put host. Participant can chat to host. That always make sure that whenever the meeting starts, first step is this only.
Okay. So this is only we can message.
You can message, they can message to you.
Okay. Not everyone can.
No, they cannot. Now whatever they are doing, no, they can even they have option of messaging separately. Then
Okay.
you will not know they are messaging.
Actually, Sanjay was laughing. Actually, see this message.
He was logging because of the emails. I was.
You know, he hide his camera something. So I just said, so he's saying so that thing.
What he was doing that time?
Laughing. I don't know.
Okay. Whatever.
Between the series.
Okay, that's what I'm saying. When meeting starts from any class, always make sure that. And second thing is here, host tools. You have to.
Oh, sorry. Yeah. Host hello.
Yeah. Okay, collaboration is only host. Unmute me. Yes. Please tell me.
9.093 10 to the power 6 joules.
This much fast you are saying means it will be wrong only. Let me tell the answer. Check. Let me check, man. Let me check.
9.
Good. Tell me how much you got.
9.093 10 to the power 6 joules.
Did by calculator or by your hand?
Calculation.
Good, man. If you.
Last year I had it with them.
Yeah, I remember. I taught this topic to you. I remember. Yes, it is. What you found is correct. Bala sir, my camera. So 9.1 into 10 to the power 6 is the correct answer. If you have got this, then it is fine. If you have not got this, then get it. I said you how to solve. Q1 will be MC delta T. What will be the value of MC and delta T? Everything you know. Q1 is MC delta T. C of what? C of I obviously. Given to you. Delta T will be how much? Delta T will become equal to minus 12 to 0. It will become equal to 12. Isn't it? From minus 12 becoming 0. What is the 12? And M is given as how much? 3 kg. Put all these things. C is given as 200. We will get Q1. Then how will you find Q2? Q2 will become equal to MLF. M is how much? 3 kg. 3 kg of ice will become how much? 3 kg of water only, no? And LF is given to you here. Put the value. You will get the value of Q2. What is Q3 then? Q3 will become equal to MC delta T once again. From 0 degree of ice to 0 degree of water to 100 degree of water. So delta T will become equal to 100 there. And C of water is how much given? 4186. And what is the mass? Same 3 kg. Do you understand? And Q4 will once again become equal to MLV. M is once again 3 kg and LV is given as 2.25 10 to the power 6. If you put everything properly and solve, you will get the answer as approximately 9.1 into 10 to the power 6 joules. Niranjan, you got the answer? Yes or no? Anshul, what about you? Did you get the answer?
Just missed the last one.
Make it fast. Try to get the answer. I'll give another question then. This is a simple basic question. I'll little bit complicated. Next question. This is a simple question. Just multiplying and adding. No concept required here. Just if you know the formula, you can get the answer. Shall I give the next question? Lokita, I got the answer.
Sir, I'm getting 10.08 into 10 power 6.
It's a mistake you are making, it means. Check your calculations. Correct answer is 9.1 into 10 to the power 6. If you don't make any mistake in calculation, you will get 9.1 into 10 to the power 6 joules only. Again, I think nothing,
9.09.
whatever, yeah, 9.09 is too accurate. I am saying 9.1. Take the next question. Last question before we wind off today's class. Last question. Happily solve it. We will wind off today's class. Yeah. Please.
So can you please repeat the answer for the question?
The question was how much heat energy is required? Answer is 9.1 into 10 to the power 6 joules. 9.1 into 10 to the power 6 joules. This is the answer. Total Q, which will become equal to Q1 plus Q2 plus Q3 plus Q4. All the 4 values are given to you. So if you find these 4 things, the final answer will be 9.1 10 to the power 6. Right, Anshul?
Yes, sir.
Okay. If you are not getting, then please check your answer. You may would have done some mistake. Okay, next question. Before we wind off, take the last question for today, please. The question is, when 0.15 kg of ice, when 0.15 kg of ice at 0 degree Celsius, when 0.15 kg of ice at 0 degree Celsius is mixed with 0.3 kg of water, 0.3 kg of water at 50 degree Celsius, 50 degree Celsius, the resulting temperature is 6.7 degree Celsius. The resulting temperature is 6.7 degree Celsius. Calculate.
6.7 degrees Celsius.
Yes. Calculate latent heat of fusion. Calculate latent heat of fusion if specific heat of water is given as 4186 joule per kg per Kelvin. If specific heat of water is given as 4186 joule per kg per Kelvin. This is the question. Practical question. I said no in the beginning. If you have ice added in water, then water will become cold. Here same question is there. Water was at 50 degree. After adding ice, it became 6.7 degree. Ice became cold water now. Water became cold water. So they are asking you to find what is the latent heat of fusion. Bala sir, please camera on.
மேலே ஈசால் கொடுக்க சொன்னாங்க அவங்க.
எங்கே கொடுக்குறாங்க? Sir, camera on. Yes. Tell me, Abhinand.
Is it 4.1 into 10 to the power 6 joules per kilogram, sir?
Loudly.
4.18.
No, 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 wrong. Bala sir, my camera, this. Yeah, fine. Coming back. So, yes, please tell me. Be little louder. Please. 3.35 10 power 5. 3 4 10 power 5.
Sir, may I present?
Yes, Pratap.
Sir, 8 point, 8, sir, I got 8204.56 joules per kilogram.
Let me check that. Please pay attention now. See how to solve this question. What they have told that 0.15 kg of ice was added in water, isn't it? How much water was? 0.3 kg, if I am right, isn't it? Water. And there are some ice cubes that is at 0 degree, and what they are doing, they are adding this ice cube inside the water. Am I right? The moment the ice goes inside the water, who will lose heat and who will gain heat? The water will lose heat, the ice will gain heat. Am I right? So, water, I should write like heat lost by the water, isn't it? Heat lost by the water to change its temperature, isn't it? To change its temperature from where to where? From 50 degrees Celsius to 6.7 degrees Celsius. Am I right? How will you find the value? The value will be Q is equal to mc delta T. How much is the value of mass of the water? 0.3. What is the value of C of the water? 4186. How much it is temperature is getting changed? 50. 50 minus 6.7, no? So 50 minus 6.7 will become 44. 43.3.
43.3.
Okay, let it be. Let it be like this itself. So this is the amount of heat that is lost by the water, isn't it? All of you agree to this? Who is gaining heat? Ice is gaining heat. First, ice will gain heat to convert all the ice to water. Then that water will go from 0 degree to 0.7 degree. Am I right? Because they told that ice was put in the water and now the new temperature of the mixture is 6.7 degree. If temperature is 6.7 degree, it means all the ice has not only become water, it has also changed its temperature from 0 to 6.7. Are you getting my point? So if I am finding heat gain, it will have two parts. First will be heat gained by ice to become water. At what temperature? At 0 degree. Latent heat, am I right? How much will be that? Q1 will become equal to MLF. LF is what we want to find, and M is how much? How much ice was there? 0.15. So 0.15 LF, isn't it? And after that, the heat is gained by the heat gained by this 0.15 kg of water to change its temperature from where to where? From 0 degree Celsius to how much? 6.7 degree Celsius. Do you agree? 2 minutes. யார் சார் பேன் அவந்திகா மேலே இருப்பாங்க, கீழே போயிட்டாங்க ஆக்சுவலாக. ஆமாம் கிளம்பிட்டாங்க, மேலே எல்லாமே கிளம்பிட்டாங்க. Coming back, sorry. So heat gained by 0.15 kg of water to change its temperature from 0 to 7. Are you understanding this? This 0.15 kg of ice first becomes 0 degree ice to 0 degree water, latent heat. Then becomes 0 degree water to 6.7 degree water. Am I right? That is also gaining of energy only, no? So how much will be that if you find Q2? This Q2 will become equal to mc delta T, where m will be 0.15, c will be same as 4186, and what is delta T here? 6.7. Do you agree? If you add this Q1 plus Q2, that is total heat gained, and equate with this Q lost, then only you will get the value of LF. Are you understanding? The equation will become like 0.15 LF plus 0.15 into 4186 into 6.7 is equal to 0.3 into 4 into 43.3. If you solve this equation, then you will get the value of LF. Are you understanding this?
8 to 0.4.
No, you have made some mistake in that. Some mistake is there, Pratap. Check your answer. The correct answer is what somebody told. I think Sai Rakshana told by seeing some book or some internet. The answer was 3.34 10 to the power 6. Or whatever. She solved it, it is very good. Whoever told the answer. The correct answer is 3.34 into 10 to the power 6 joules. Sorry, not joules, joule per kg. It is latent heat. Got it? Good. Yes, yes, yes. Sai Rakshana, solve by yourself?
Yes, sir.
Appreciate it if you are really solved by yourself, really. Otherwise, I am not going to see, but God is not going to forgive. Okay, good, Sai Rakshana, good, good. If you are solved by yourself, I should appreciate also. Get a chocolate from me in the next class, if you see me. Okay, so shall we wind off? Obviously. I'll share some worksheet with you from this topic. If you solve the questions of calorimetry, believe me, you will get interest in this topic. If you solve 3, 4, 5 more questions, no, it will be very interesting topic. And remember that many questions are going to come from calorimetry in the competitive examination. If you are going to write VIT EEE, JEE mains, NEET, expect question to definitely come from calorimetry. The same question, same kind of question, little more complicated, right? So I hope whoever joined the class in online or offline, everybody understood everything. If yes, then you can drop off. Bye bye, good night, and we will meet again on the next Tuesday. Till then, take care. Bye bye.